In this code, we are using a cadet library to detect the encoding of a file named span CVS. First, we open the file in the binary mode RB and read its content. Cadet analyzes this content to determine the encoding, returning the result as a dictionary. We then use the detected encoding to properly read the CVS file using panda read CVS function. This process ensures that the data decoded correctly, preventing any potential encoding related issue when working with the CVS file. In this code, we are loading a dataset from a CVS file called span CVS using panda. Since the file encoding is specified as a window 1252, we ensure it properly decoded during the bidding process. After loading the dataset, we rename the column for clarity, assigning them with a meaningful name like label and SMA. This step aims to improve the understanding of the dataset, making it easier to work with an analysis or further processing. In this code, we are leveraging the NLTK library to perform text processing on the dataset. First, we download the necessary data including stop word and func tokenizer. Stop words are common words like the or is, which often don't carry significant meaning in the text analysis. Punctuation marks are also defined. Then, we determine the preprocessing function called preprocess, which converts text to lowercase, remove punctuation, tokenize the text into word, and remove stop word. This function helps in cleaning the text data, making it more suitable for natural language processing tasks. Finally, we apply the preprocessing task to the SMS column of the dataset, creating a column called process that contains pre-processed words.
So next, we use the first two lines of code to split our data into process X and label Y. In process X, we use all the data to train our model, while in label Y, we want to train our model to predict either the message is spam or ham. And then we use the train test split to test and train our model. So in X train and Y train, we use all the data to train our model, and X test and Y test is use the data to test our model. So the test size of 0.2, it means 20% of the data will be used for testing, while 18% of the data will be used for training. As for the random stack of 32, it means it will generate a random number and will ensure that our model works accordingly. Then we vectorize the text data using count vectorizer. So it means it converts the text data into matrices that can be read by our machine. So inside the count vectorizer, we also use stop words to remove excessive words such as the, is, in to reduce the noises in our data. Then we train the vectorizer using vectorizer feed transform, which it transfer the vocabulary that it learned into matrices that it can be read. Then we text the vectorizer, which transform all the applied text data into numerical format based on the vocabulary that it learned from the training data.
So next, X-train vectorize. This is the training dataset of the being transformed or vectorized. It typically represents textual or categorical data that has been converted into numerical form suitable for machine learning algorithm. While training, this is corresponding target labels for training data. For the supervised learning, tasks like classification plus label represent the class or category is samples belong to. So the provided code is decision tree classifier, set each random state and then feeds to the training data. X vectorized along with their corresponding labels. Y trains. This the process trains the decision classifier to learn pattern in the data that can be used to predict the labels of unseen data. Okay, next, predict X test vectorize. This is method takes the text data X test vectorize, which should be in the same format as training data but not seen by classifier during training, and predict the label for it using the train decision tree classifier. Y-print, this is variable hold to predicted labels for the test data. Once you have Y-print, you can use various evaluation metrics to access the performance of the classifier such as accuracy, precision, recall, F1 score. This code calculates accuracy and generates a classification report which provide detailed metrics such as precision, recall, and F1 score for each class in the classification task. Adjust the evaluation metrics as needed based on the requirements of.
In our project, we use two key tools from the sklearn.metrics module, accuracy score and classification report, to evaluate our machine learning model. The function calculate accuracy and report takes three parameters: the test data that has been vectorized, X test vectorized, the true labels Y test, and the classifier we are evaluating. The function follows these steps. First, prediction. The classifier predicts the labels for the test data, which is X test vectorized. Second, accuracy calculation. We calculate the accuracy of these predictions by comparing them to the true labels Y test using accuracy score. Third, classification report. We generate a detailed classification report using classification underscore report, which includes precision, recall, and F1 score for each class. The function prints both the accuracy and the classification report, providing a comprehensive overview of the model's performance. This process helps us understand how well our model performs and identifies areas for improvement. To predict whether an SMS is spam or not, we use the predict SMS function. This function takes three inputs: the SMS message, a vectorizer, and a classifier. Here's how it works. First, pre-processing. The SMS message is pre-processed and transformed into a format suitable for the classifier using the vectorizer. Second, prediction. The classifier predicts whether the SMS is spam or ham, which is not spam. Third, probability calculation. The function also calculates the probability of the SMS being classified as spam or ham. If the SMS is classified as spam, the function returns a message indicating it's spam with the confidence level. Otherwise, it indicates that the SMS is ham, again with the confidence level. This function allows us to predict and understand the likelihood of an SMS being spam or not, enhancing the effectiveness of our spam detection system.
Users are prompted to input a message that the suspect might be spam or ham. This user input is collected using the input function as shown on the screen. This input is processed by our predictive model through the predict_SMS function. The function leverages a trained machine learning model to analyze the content of the message and predict its classification. This step is crucial as it demonstrates the practical application of our model in real-time scenarios. The prediction result is displayed on the screen. The result includes the classification of the message as either spam or ham, along with detailed metrics such as accuracy, precision, recall, and F1 score. These metrics provide insight into the model's performance, showing a high level of accuracy and reliability. Additionally, a sample message is classified to illustrate the process, reinforcing the model effectiveness in distinguishing between spam and not spam messages.